Hello again everyone, my name is Mharlyn and for today I will be recording my submission for laboratory exercise number 8, IT211 Data Communications and Networking 1, CISCO 1. The title for this activity is 1 Configuration and Routing System. We have already established a LAN connection in our experiment 5. We learned that with the right IP configuration and a proper routing protocol, there will be a communication. It is also important to have the same network in order to send information without a premise. The problem still arises: what will happen if there is a different network in a wired or wireless environment? The solution is a WAN connection that will be discussed in this experiment. At the end of this course, we are expected to distinguish different networks in a network system. Establish a WAN connection by connecting LAN to LAN. Configure router to router. Materials that we need is a CISCO packet tracer. Procedure 1. After doing the experiment Lab 5, we will now establish a WAN link. We have to make sure that experiment 5 is completed before proceeding in this experiment. In configuring the WAN connection, we have to click on the CISCO WAN router and select config mode. Procedure number 2. In configuring a WAN connection, click on the CISCO_WAN router and select config. Number 1, click on the CISCO WAN router and select the config tab. Then click on RIP. No, delete it from here. Number 2, in configuring the WAN connection, click on the CISCO WAN router and select config mode. Choose interface serial 000. Four, configure the interface serial 000 by designating the IP address to 192.168.2.1, then press the tab key and enter the subnet mask 255.255.255.0 on the interface. Number 5, set the clock rate to 5600. Number 6, enable the port status to on mode. Number 7, click on the new router and select the config mode. Change the display name and host name to CISCO 2. Number 9, configure the interface serial 000 with the IP address 192.168.2.2. Then press tab and enter the subnet mask 255.255.255.0 on the interface. Number 10, again, enable port status to on mode. Note, the indication that the link is successful is when the serial link, the red blinking light should change to green, showing that the link is active. Configuring the routing protocol. Step 1, click on the CISCO 1 and select Config tab. Then click on RIP and add the network address 192.168.1.0 192.168.1.0 and 192.168.2.0. Procedure number 2, click on the CISCO number 2 router and select the Config tab. Then click on RIP and add the network address 192.168.2.0. Step 4, in setting the default gateway on the PCs, enter the default gateway address 192.168.1.1 and click it on PC0, PC1, and PC2. Number 5, test the connectivity of the network by clicking on the simulation mode. Question number 1. What is the difference of LAN connection to WAN connection? A LAN, or local area network, is a group of computers and network devices connected together, usually within the same building. By definition, the connections must be high-speed and relatively inexpensive. Example, token ring or Ethernet. A LAN connection is a high-speed connection to a LAN. A WAN connection, in comparison to MAN, is not restricted to a geographical location, although it might be confined within the bounds of a state or country. A WAN connects several LANs and may be limited to an enterprise, a corporation, or an organization, or accessible to the public. The technology is high-speed and relatively expensive. The Internet is an example of a worldwide public one. A computer network simply means any set of computers and other devices like smartphones, smart TVs, video game systems, and routers that are able to communicate back and forth with each other. Different protocols or rule systems exist that let computers understand each other and transmit data. A LAN or local area network is a small network, often within a home or business, or perhaps within a large environment like a corporate office park or a college campus. Devices on a LAN often use the LAN's infrastructure to connect to the public internet, but they can often communicate with each other directly through the LAN more quickly. For instance, it is not usually necessary to send a file to the public internet in order to get it to a printer on the same LAN. A LAN can use wireless communication, wired connections, or both. A wide area network usually traverses multiple geographical areas. The Internet is the most prominent example of the WAN network type. Though other wide area networks exist for scientific purposes, military and government work, and to connect far-flung offices and data centers within some big corporations. Question number 2. Can we establish a communication from one point to another having the same network? Yes, we can establish a communication from one point to another having the same network. A network is a collection of computer or other devices commonly called nodes that are able to communicate with each other. This communication takes place on different network levels. A network may use the Internet protocol at one level and Internet at the level directly below it. This distinction is important because some parts of the network operate at the IP level and others at the Internet level. Here is the basic network architecture. In this figure, middle box is called a hub A. The hub A is a box with lots of connections or sockets for Internet cables. The hub repeats all messages it receives to all connected nodes, and these nodes filter out only the messages that are intended for them. This filtering takes place at the Internet level. Incoming messages carry the Internet network address of the intended recipient. A problem with this approach is that hubs generates a lot of traffic, especially on larger networks. Most of this traffic is wasted since it is intended for only one node but is sent to all nodes on the other network. The second figure shows you a basic network with a hub and a switch. A commonly used solution today is a switch. A switch connects all nodes to each other, just like a hub, but is more intelligent in which messages are passed on to which node. A switch examines incoming Ethernet messages to see which nodes is the intended recipient, and then directly and only passes the messages to that node. This way, other nodes do not unnecessarily receive all the traffic. The way computer networking works are in layers. The layers in the OSI model are shown on the screen above. In order for two computers to communicate over a network, they must be speaking the same network layer protocol. It doesn't have to be IPv4 or IPv6. It could be IPX or X.25. We'll just assume IPv4 since that is the most common. Both computers will need an IP address, and in this day and age, most likely they will assign one from a DHCP server or will dynamically assign their own using zero-con since they will have IP addresses. Question number 3. Why do we need to configure the router? In a single network, at the Internet Protocol level, even when the network is segmented, all nodes are still able to communicate with each other. To connect the networks, a router or gateway is used. A router is an inexpensive device. This is basically a box that goes between your DSL or cable modem and all of your internet devices like computers, HDTV, and so on. The router shares the internet signal between the multiple devices. The main role of the router is to forward the message or packet based on its IP location. Each message comes at the router with a destination IP. The router then looks up that IP in its lookup table and forwards the message to the destination IP. Routers not only share the internet connection, they also put your computers onto a local network so you can share files and printers between them. Thank you so much once again for being with me in my laboratory number 8. Once again, I am very much humble and thankful for getting through each and every part of my laboratory and checking on them one by one. Please be with me on my next set of laboratory on my next subject for this course.